This lesson is on the counting principle and permutations. We've already learned about tree diagrams, and tree diagrams are helpful when we want to know what all of the possible outcomes are and what order things happen in. But with the counting principle and permutations, we're really just looking for a total number of ways something can happen. Let's go back to this same example of our lunch choices. We have a choice of a taco or a burrito for our entree, and then we choose one side item. We have rice, beans, or a salad, and then we have the choice of water or lemonade. We can make a tree diagram for this, but if all we want to know is how many possible outcomes there are, instead of what are the possible outcomes, we just want to know how many, then what we look at is how many choices are we making? Well, we're choosing an entree, then we're choosing a side item, and then we're choosing a drink. So we draw a blank for each choice we make. How many entrees there are, a blank for our side items, and our blank for our drinks. There are two choices for an entree, a taco or a burrito, so we put a 2 in the first blank. Then there are 3 choices for side items, so we put a 3 in the blank for side items. And then when we choose a drink, we have water or lemonade. That's 2 choices, so we put a 2 in that blank. And so we have 2 times 3 times 2, so 6 times 2 is 12, which is what we would see if we made the tree diagram. In this example, we're wondering how many possible outcomes there are if you flip a coin 3 times. So for this one, we would draw 3 blanks because we're repeating our experiment 3 times. If you're repeating something over and over, the same experiment, whether it is rolling a die or flipping a coin or whatever it may be, you draw a blank for each time you do the experiment. So this would be the first flip, the second flip, and the third flip. We're flipping a coin, and there's 2 possible outcomes on a coin, heads and tails. So there's 2 possible outcomes on the first flip, 2 on the second flip, and 2 on the third flip. So 2 times 2 times 2 is 8. This is called the counting principle when we're drawing blanks and saying how many choices we have for each thing. In this problem, there are 5 questions on a true-false test. How many ways can I answer the 5 questions? Well, we know that for each question you can either write true or false, so there's 2 outcomes. But we're answering a question over and over and over. Each time it's a different question, but each time the same outcomes are possible. So this works a lot like flipping the coin. We're going to answer 5 questions. 1, 2, 3, 4, 5. There aren't 5 options for each one. There are only 2 options. So there's 2 options the first time we answer a question. It could either be true or false. For the second question, it could be true or false. For the third question, we have 2 options. For the fourth, 2, and for the fifth, 2. We're doing the same thing over and over. We multiply these. 2 times 2 times 2 times 2 times 2 is 32. So there are 32 different ways to answer a 5-question true or false test. One example might be true, 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 but then you could do true, false, true, false, true, and you get the idea, all those possible outcomes. If there are 5 runners in a race, how many ways can we award first and second? This is a little bit different because we're talking about only 2 places and we have 5 runners to choose from. Well, this means we're making 2 choices, a first place choice and a second place choice. Well, when the runners run the race, all 5 of them have the possibility of coming in first. But once someone has crossed the finish line first, they can't also be awarded second. So we only have 4 people left to award second place. So 5 times 4 is 20. There are 20 ways to award first and second place. This is called a permutation. In a permutation, it's a special kind of counting principle where the order that the people are chosen is important. It's important who gets first and who gets second. So the order there matters. This is called a permutation. We'll talk a little bit more about permutations in a minute. We're going to talk about them right now. The arrangement of a number of items in a definite order is called a permutation. So what kinds of things would that be? Situations that would be permutations would be like the example we did, awarding first, second, and third place for any reason, choosing president and vice president, arranging the letters of a word. Sometimes you'll see a problem that will say, how many ways can you order the letters of the word bean? And you'll need to figure out how many ways you can do that. That would be a permutation. Also, anytime you're putting something in a line or on a shelf or in a row, the order that you put them there matters. We might say, oh, I don't care what order things go on the shelf, I just put them on the shelf. But when you think about those problems, think about yourself as a librarian. Does the librarian care what order the books are on the shelf? Definitely. They have a very specific order. So the order matters. When you're talking about putting things in a line, think about kindergartners. Do they care where they are in line? Yes. It's important if you're in the front or if you're the caboose or where you are in the line. So kind of thinking about it like that. These are when order matters. The formula for permutations looks like this. N, P, R. N is the number of items that you're choosing from, and R is the number that you're choosing. For example, in our race, we had 5 runners, and we were awarding 2 places, first and second. So N would be our 5 runners, and R would be the 2 places. The way we solve this is to do N factorial over N minus R factorial. If it's been a while since you've seen the factorial sign, it's just like this. If you do 6 factorial, what that means is you're going to multiply 6 times every positive integer less than 6. So 6 times 5 times 4 times 3 times 2 times 1, and you would multiply that out. If we had 4 factorial, then we would start at 4. 4 times 3 times 2 times 1. So let's go back to our formula, N factorial. Well, our N was 5, so this would be 5 factorial. And then we need to do N minus R. Since R is 2, we're going to do 5 minus 2, so that's a 3 factorial. To solve this, we go ahead and write it out in expanded form. 5 times 4 times 3 times 2 times 1 for the 5 factorial over 3 factorial. 3 times 2 times 1. It's important to recognize that this is all multiplication, so there's a lot of canceling that can happen. You might look and say that's a lot of computation, but if we look, our 3's cancel, our 2's cancel, and then the 1's don't make any difference. So we have 5 times 4 over 1, which is just 20. There are 20 ways. You'll notice that's the same answer we found when we drew the blanks. When you're dealing with permutations, you can either use the formula or you can draw blanks. It kind of depends on how large your numbers are. The calculator will do this for you if you want to use the calculator, but it's also important that you be able to work them by hand. So if the numbers are small, doing it by hand makes sense because so much of it cancels out. If the numbers are large, then you'll want to use a calculator.